Hi, hello everyone. This is Nepali sir from ANR Academy. Today we are going to discuss how to remember the expansions of e power x, a power x, sine function, cosine function, tangent function as well as log of 1 plus x. These are the expansions helpful on problem solving limits topic. Most of the students feel difficulty to remember all these expansions, but there is only one way to write all the expansions of these functions: e power x, a power x, sin x, cos x, log 1 plus x and tan x. With the help of Maclaurin series, we can easily expand all these. So here we have to remember different expansions, but with the help of Maclaurin series, just if you know the formula how to expand the function f of x with the help of Maclaurin series, using that you can expand expansion for these functions. And let us see, this is Maclaurin's expansion. If f of x is given, then that can be written as f of 0 plus x into f dash 0 plus x square by 2 factorial into f double dash 0 and so on. Here it is very easy to remember. Here we have first term f of 0, next term exponent of x1, in the denominator part you have 1 factorial and first derivative. Next, exponent of x2, in the denominator part you have 2 factorial and double derivative. In the same way, if you continue, you will get the expansion of f of x. Let us see the expansion of e power x first. Let us suppose f of x equal to e power x. We need all differentials. F dash of x, that is again e power x, f double dash of x, again e power x, third derivative also the same e power x, and here the value of f of 0, that is e power 0, become 1. Next, first derivative at x equal 0, also 1. In the expansion, we need f of 0, f dash 0, f double dash 0, also it is 1. So on continuation, third, fourth, fifth derivatives at x equal 0 become 1. Now substitute all these values in this standard result. You have f of 0, here you have to write 1. Next, f dash 0, here 1. F double dash 0, also 1. On continuation, nth derivative also 1. And here the function f of x clearly e power x. Now let us observe the expansion. You have 1 plus x square by 2 factorial and so on. So this is the expansion of e power x. In the same way, let us discuss about the expansion of a power x and then we go for sin x. Let us see the expansion of a power x. A power x, that can be written as e power log of a power x, that is equal to e power x into log a. We know the expansion of e power x. It's very simple compared to remaining expansion. E power x expansion 1 plus x square by 2 factorial plus x cube by 3 factorial plus x power 4 by 4 factorial plus and so on. Now you have here e power x log a. This is same as a power x. With the help of expansion of e power x, now I am going to write expansion of a power x. That is clearly e power x log a, so that wherever x there, now you have to write x log a. So 1 plus x log a, next x log a whole square divided by 2 factorial plus x log a whole power 3 by 3 factorial plus and so on. So in this way you can remember the expansion of a power x. Let us discuss the next expansion of sin x. Suppose f of x equal to sin x. First derivative I am going to write. First derivative sin x derivative cos x. Next derivative cos x derivative minus sin x. Next third time derivative minus cos x. Next fourth derivative I am going to write, this is plus sin x. But in the expansion we need f of 0, f dash 0, f double dash 0, f triple dash 0 and so on. And you know the expansion of f of x, that is f of 0 plus x into f dash 0 plus x square by 2 factorial into f double dash 0 plus x cube by 3 factorial into f triple dash 0 plus x power 4 by 4 factorial into f fourth derivative at 0 and so on. It continues. See here, when you put x value 0, sin 0 becomes 0. Next, in the first derivative, in place of x, if you replace 0, cos 0 value become 1. Next, double derivative at 0, that is clearly sin 0, 0. Next, third derivative at 0, cos 0 value 1, so that minus of cos 0, minus 1. And then fourth derivative 0. Now substitute all these values. What is f of x? Clearly that is sin x. F of 0, 0 it is. Next x into 1, next term 0, and then you will get x cube by 3 factorial into minus 1 plus 0 and so on. Therefore the expansion of sin x, first term x, next term with a negative sign, x cube by 3 factorial, and then you can guess the terms plus x power 5 by 5 factorial, after that minus x power 7 by 7 factorial plus and so on. So this is the expansion of sin x. In the same way you can find the expansion of cos x also. Let us discuss next expansion for log 1 plus x. Suppose f of x equal to log of 1 plus x. Its first derivative 1 by 1 plus x. Next derivative 1 by 1 plus x derivative minus 1 by 1 plus x whole square. Next expansion, third derivative minus 2 divided by 1 plus x whole cube, one more minus sign, plus 1 plus x whole power minus 2, outside minus sign. So minus 1, next 1 plus x power outside minus 1 is there. 1 plus x power minus 2 derivative minus 2 into 1 plus x whole power minus 3, and simplification we get this result. Next, fourth derivative I am going to write, that is 6 along with negative sign 1 by 1 plus x whole power 4. Actually this is 2 times of 1 plus x power minus 3. Its derivative 2 into minus 3 into 1 plus x power minus 4. On simplification you will get this result. Now I am going to write the value of f of 0, that is clearly log 1 become 0. Next f dash 0, 1 by 1 plus 0, clearly 1. Next its double derivative at 0, minus 1. Third derivative at 0, just 2. Next fourth derivative at 0, that is minus 6. Now substituting in the Maclaurin's series of expansion, f of x, you know that f of 0 plus x into f dash 0 plus x square by 2 factorial into f double dash 0 plus and so on. So now you can write the expansion of log of 1 plus x, that is first term 0. Next x into 1, that is x. Next minus x square by 2 factorial, value 2. Next x cube by 3 factorial multiplied by this. Next plus sign x cube by 3 factorial multiplied by 2 gives the result 3. Next x power 4 by 4 factorial, value 24, and here you will get minus 4 plus and so on, so that the expansion of log 1 plus x finally x minus x square by 2 plus x cube by 3 minus x power 4 by 4 plus and so on. Alternate plus minus sign you will get. So in the examinations, if the problems based on limits concepts, suppose you have, then in such cases you can easily expand with the help of Maclaurin series. So using this you can simply expand all the expansions for e power x, a power x, sin x, cos x, tan x, log 1 plus x, which we discussed just now, right? And these are actually the standard functions in standard limits. You know that limit x tends to 0 sin x by x1, there you have standard function sin x, and you have limit x tends to 0 tan x by x, also 1. So standard function here, tan function. You have limit x tends to 0 log 1 plus x by x, and also you have limit x tends to 0 e power x minus 1 by x formula, a power x minus 1 by x formula. So on problem solving they may use the expansions. So this is the way to remember all the expansions with one formula, that is Maclaurin series. F of x is f of 0 plus x into f dash 0 plus x square by 2 factorial into f double dash 0 plus x cube by 3 factorial into f triple dash 0, and so on, it continues. So this is the way of remember the expansions within one formula. Thank you so much.